Do you constantly get null reference errors because objects can't find each other and you are missing references? Do your objects depend on each other like some mad, crazy spider web? Do you wish you could upgrade your variables and give them extra information and maybe even functionality? Oh, and does this happen to your code when you make one small adjustment? In this video, I will provide you with a nice solution to those problems by introducing you to the power of scriptable objects. They often sound a bit intimidating for beginners, but please don't panic and run away like those guys down here. I mean, after all, everyone here survived and was fine, and the ones that ran away kinda embarrassed themselves. Scriptable objects really aren't that complicated, but they can make your life in Unity so much easier. And understanding how they work means you understand a lot about how things work in Unity in general. So let's do a bit of theory and then we're gonna look at some practical examples to see how it works in code. To understand scriptable objects, it's important that you understand the big difference between your files on your hard drive and the scripts that you write, and the instances, the copies that get created at runtime and that you use when the game is playing. The project folder right here is literally files that are on my hard drive. So when I create a new script, I'm creating a new file. The scripts on our hard drive are basically blueprints. We define some fields and some logic. But during the game, we use instances, meaning copies based on those blueprints. Those instances are not created on your hard drive, they are created in memory. So when the game runs, they get created. When the game stops, they get wiped from memory. Every instance can use different values for the fields, and of course we decide when we want to call those methods, the logic, and make them behave all differently. In Unity, there are two main ways to create those instances at runtime. You can always create an instance of a script in another script simply by using instantiate. And of course, when we instantiate a prefab that has the scripts on it, what we're doing is we're creating instances of all those scripts. And the other main way is through the editor by building our scene. We populate the scene with game objects and we can attach scripts to them as components. This might seem like we're already creating instances, but basically we're just telling Unity when the scene starts, I want you to create an instance of this and of this and of this and do this all in memory. So here I have this bulky game object, it has 3 scripts on it. And when the scene starts, I'm saying, okay, I want 3 instances of this script on this game object. And the nice thing is I can also set different values for every game object here. So here I might increase the walking speed. And now when I click play, Unity is going to take all this information and create all the instances that I need at runtime. The switch is pretty much invisible, but that's a feature of Unity. Right now I'm looking at an instance of those scripts. A good clue is that you probably came along is when you try to change some values and you think you found just the right amount, the perfect values, and then you click stop and the instance gets wiped from memory, and that means all the values are gone too, because once again you're just looking at the plan for the scene. I see the editor a bit like a shopping list. You know, you can say, okay, I want a creature like this one. I want to place this one here and this one here, and also give me a sun. And then you got like those little post-it notes, meaning you can change the values to say, okay, I want this creature to be really fast and this creature has different values. But the important thing is all of this is still happening on your hard drive because there's a scene file. Every time you have a scene, you save it on your hard drive. And that scene file has all those informations in it. With scriptable objects, it starts the same way. You just right click here in your projects folder and you create a new script, a new C# script. And so you just create a new file on your hard drive. And to turn it into a scriptable object, all you have to do is replace the mono behavior with scriptable object. And don't forget to add the create asset menu attribute right above the name of the script, because that is going to allow us to right click in the project folder and create an instance of this script. Now you might be wondering, why do we create an instance in the project folder? And that is exactly what the big difference is with a scriptable object compared to mono behavior and classes. Every instance is another file in your project folder on your hard drive. You cannot put those instances into runtime. You just create them one by one by just right clicking, and every time you can get a new instance. So in this project, I have a scriptable object called float.so, and I have the create asset menu attribute. So I can right click and then choose here float SO. So now I created a new instance of the scriptable object, and I can give it different values based on the fields that I defined in the script. And here before I have already created two instances called global light and global temperature. You can give them any name you want. When you click on the instance, you can still see it right on the top what this instance is a copy of. Now you might be wondering, what's the point of a script where I have to create every instance by hand? That sounds incredibly tedious. And the big advantage of scriptable objects really is you know where they are. They are right there on your hard drive. They're always going to be there. When you build a scene with mono behaviors, it might be quite common that in a wake you say find object of type, find this one, and then you have to say, wait, but this object also needs to know about another object. And then of course, every time a new object gets spawned, like a new creature, they have to know where the sun is. So they have to find the sun, and maybe actually the sun needs to know about every creature too. And sometimes creatures die, they get killed, they get shot in the head. I mean, it's a game. So things get instantiated and destroyed in memory all the time. It's highly dynamic. And so it gets pretty messy when you try to keep all those things connected. And then of course, when you try to call a method on a reference of an object that doesn't exist anymore, you get an error, and this could be a game-breaking bug. Like all the time you put into your game, it's just down the drain because of this one damn missing reference. Now there's one more thing we should talk about, and that is prefabs, because prefabs can really leverage this advantage that you know where the scriptable object is on your hard drive. Because prefabs, they also sit on your hard drive, right? You create your game object, give it some scripts, and then you drag it into your projects folder to convert it to a prefab. So I see prefab kind of like a collection of blueprints, right? You can have your game object with a bunch of scripts, can have one script, doesn't matter. And then you have those little sticky notes because you can like preset all those values of the script. And then when you instantiate one of those prefabs, what you're doing is you're instantiating an instance of every one of those scripts that's sitting on the prefab. Since the prefab is sitting on our hard drive and the instances of the scriptable object as well, you can already make that connection. So you can tell the prefab, hey, the scriptable object instance that you probably want to know about is right there. You just drag that in the inspector, and I'm going to show you in a moment. So every time now when you instantiate an instance of that prefab, it already knows about that instance of the scriptable object. And of course, you can do that with different prefabs. They can all reference the same instance of the scriptable object, and they can use it to communicate. And now they don't have to find each other like the normal instances of the scripts, all your creatures, the sun, the mushrooms. They just communicate through the scriptable object, and they're always going to know where it is. It's always going to be at the same place. Okay, so let's take a look of a practical example. I've built this little demo scene on how we can utilize this advantage of a scriptable object. Let's start with the thing itself. The script that I created, the scriptable object, it's called float SO, and it's a scriptable object that is based around this float value. So let's take a look at that script. As I mentioned before, I use this create asset menu attribute above the name of the class, so I can easily create the instances with right clicking. Then I have a public sprite here for the icon sprite. This could be really useful when you use this in a UI element, a string for the name, and the most important thing here is this float field. It's just called value. It's a private field, so other scripts can't just change the value, but there's a public getter in case any script just wants to know what the value is. And to change this, I have these two methods. So they are public. Anyone who has access to an instance of this can just change the amount. The first method is called change amount by, and the other one is set new amount. Just because sometimes I have some other scripts that want to say, okay, increase this value by 5, and other times I just want to say, no, set this value to 10. I don't give a damn what the value was before. And in both cases, I make sure that the value doesn't go below minimum or the maximum, above the maximum. And I just use this math f.clamp. It says the first parameter is the value that you want to clamp between the second and the third parameter. And of course, those are just serialized fields that I can set in the inspector, and they can be different, of course, then for every instance that I create of this script. For the min and max value, I also made public getters, so other objects can at least request to know what the value is and they can work with it. And we're gonna see some examples later on. I should also give you a little preview with this set to initial amount, because there is a bit of a problem with scriptable objects. Since they don't live in runtime, they keep all their values, so you have to reset them. But we're gonna do that in the end. The more important thing right now is this action event here. Just make sure you use system, because that's the namespace that it lives in. And it's just a handy way of writing a delegate in one line. And I'm setting this event to an empty delegate, just in case it gets called and no one is listening to it. Otherwise, you would get an error message. But if you just do it this way, you're never gonna get the error and you can just call the event. And we're doing this right here in the change new amount and set new amount. And so the event, it just gets sent out into the void. The instance of the scriptable object doesn't care who's listening to it. But then other scripts can say, okay, every time this value changes, I would like to get informed by listening to this event. Okay, this is pretty much it for this. This is all the scriptable objects we're going to use in this example. So let's go into the scene and see how other objects and classes can use instances of that script to communicate with each other. The script that's going to change those values is the Sunswip. So the sun is just a prefab, it has light and it has the Sunscript. And as you can see, it references both instances of my float SO scriptable object. Like any good sun, it basically just goes up and down. It goes up, the light increases and the temperature increases. And here I set it so when the light increases by 1, I want to increase the temperature by 5. And when it's at its highest, it's gonna go down again. So let's take a look at that script. So here I have a bunch of serialized fields that you just saw and a reference to the actual light. So you can set the min intensity and the max intensity, and it's just gonna go up and down between those two. The important thing is, of course, the reference to the instances of the float SO scriptable object. And we're just doing this like we would do with any other script in Unity. You just say like a private, and then you can say any kind of class you have. Could be a mono behavior or scriptable object, could also be a class without a mono behavior. Then you give it a name. And then you can assign an instance of this into this field. So with the creature script, you would get like any kind of creature that is living in the scene. And this is what I was talking about before. You can do that in the prefab. So the sun is a prefab that has the instance of this script. And I can already assign those references and they're never gonna get lost. I can instantiate all the suns I want. In the awake method, I'm doing a bit of a dirty hack, is what I also mentioned before. The scriptable objects are not going to reset their values. So I need some script that does that for me. And I'm just doing it here in the sun, and I'll explain more about that later. So here in the start method, I just add the current intensity and the heat. And then I use this invoke repeating, which I wouldn't recommend. I just wanted to keep it really simple. Invoke repeating just says call this method after this seconds and then repeat that every X seconds. That's the last parameter. Usually I would use a coroutine because invoke repeating is very error prone. If you make a typo, it's not gonna work, but you're not gonna get an error message. So that can be very frustrating. But yeah, I just want to keep it simple for this example. So let's just go with invoke repeating. It looks the easiest. Also on a side note, if you want to have the sun rise smoothly, you should play around with sine waves. They are made perfect for that. But for the sake of this tutorial, we are really just making the sun go up and down in a very linear, non-natural way. But so you can see here, when we are rising, we set the intensity and we change it by a second. And when we reach the maximum, then we're gonna go down. And the important thing is, every time we do that, we tell the instance of the scriptable object that we want to change the amount. And as you might recall, that means we're also now triggering the event in the instance of that scriptable object. And let's see who's listening to that event. The most important one is this bulby prefab. It has 3 scripts on it. The first one is just so that it walks around. It just walks from point A to point B, and when it arrives at point B, it chooses another point. They're kind of stupid because their brains are light bulbs. The next script is the skin color adjuster, and that is going to change the color of them based on the global temperature. So when it gets cold, they're gonna start turning blue. And so let's take a look at this one. Here on top we have a reference to the renderer and then the material, and that's just to changing it. And of course the temperature at when we want to start turning blue. And here we have a reference to an instance of this float SO, and it is of course the same instance that the sun is referencing. So the sun is changing it and this script is listening to it. In start, I just first save the color that it started with, so this orange, and then I calculate the cold range. I just use that range in the adjust color temperature method. And the important thing is in onEnable, we are subscribing to the global temperature, the instance of the float SO, the value changed event. And what we're saying with this line is every time that event gets triggered, we want to trigger the adjust color temperature method. And therefore we are only calling this adjust color to temperature method when the temperature actually changes. And as you remember, the sun is setting that value and it says the change amount by, and that is triggering the event. And I'm also going to show you how to do that with a slider. So like any kind of script can change that. This script here, the change skin color, doesn't care about who actually changed it. It only cares about that it changed. And so when that happens, we just check what the new temperature is. And then we're going to calculate how far we are between the orange and the blue. And then we set that to the skin material. And down here, very important, in onDisable, which gets called when the game object gets destroyed, or rather when this instance gets destroyed, is that we unsubscribe from this event. Because if we don't, Unity might actually keep this instance around in memory and still call that method even though you don't see the game object in the scene anymore. So when you subscribe to an event in onEnable, always unsubscribe in onDisable. Just use a minus, and that's really all there is to it. Okay, this is it for the script. So here's another example that is commonly used for this technique, which is the UI. That can just represent this value, and again the UI doesn't care who's changing it. It just says, okay, every time this value changes, I'm going to display that. So it's just a text, it has reference to this, and as you can see here, it's pretty much the same. What in onEnable we subscribe to this event, so every time that changes we are going to change the text, and in onDisable we're going to unsubscribe. Another example of a thing that can react to this is on the Bulb script, is this Lightbulb script, and it does pretty much the same as the change skin color. It listens to the global light, and if the value is below a certain threshold that we can set here, it's just going to turn on this light bulb. And it's just going to do that by turning on a point light, which I put inside this light bulb, and to make it look a bit nicer, also going to change the material to this emissive material. And yeah, we're gonna hit play soon, don't worry. Let's just take a real quick look at this script. Once again, we are having a reference to one of those instances of the float SO. We're doing this right here, and of course we're doing that in the prefab, dragging in this reference. And in onEnable, we're going to listen to the event, and then we're going to toggle on the light bulb. Based on if it's already on, I just changed that in a bool, so we don't have to change the material all the time. And then we see, okay, if it wasn't on, then we're going to turn it on, and otherwise, depending on the light, we're going to turn it off. And of course, in onDisable, we unsubscribe. So let's hit play and see all of this in action. The sun is going down now, so it's changing the global temperature and the light. The UI is picking up on that event. And of course the bulbies, they're also listening to it. So the light is now below 1. So they checked, oh, okay, we need to turn on our lights because we need to see where we are walking. And the sun rises again. And I think I'm speeding up now. So when it gets really hot, oh, there is another thing. And that is also interesting because this smoke is a nested prefab. It's a particle system that has a script on it, and it listens to the temperature, and then I define, okay, when it gets really hot, I want to emit those particles, this number of particles per second at maximum. And again, it's pretty simple. We just have reference to the particle system and of course to our float.so instance. And here, I don't know if you're familiar with particle systems. I have a whole video on it. If you want to change it through the script, you have to get a reference to the subsystem, and of that subsystem, you can then set the values directly. It's something to do with a custom interface for particle systems. Anyhow, point being is, it's all the same. On enable, we subscribe, do it, and then on disable, unsubscribe. So the cool thing is, because this is a prefab, we can attach this thing to anything. And it's already like hooked up to the instance, like the global temperature. So for example, I could say, you know what, I want the mushroom here to also smoke. And I could even do this at runtime, like things don't need to know about each other. Everyone already knows what they have to know. And yeah, then the script just works. I also have this little slider here. Once again, another script, also references the scriptable objects. No one knows about it, only I do because I'm playing God here. So I can just crank up the temperature. The sun is going down, it's trying to save those little creatures, but I can keep cranking it up. Or I can just set it all the way down, and now they're turning blue because it's cold. And now the sun is rising. The sun is kind of trying to be nice to them. But yeah, let's keep it cold. Or maybe let's go all the way hot, and they're smoking again. Okay, the last example I have here is this mushroom script. And this one actually listens to both of those instances, because it's checking when it should grow, and it does that based on temperature and the light. Like both conditions have to be just right. And I'm saving those in a vector too. It's just a handy way to keep two values together. Has nothing to do with position. It's just vector x. The x value is the minimum and the y is the maximum. So I have one for the temperature and one for the grow light range. And here I just do one thing a little bit different. I just call this method every second because they're kind of growing constantly. You could of course also make a bool and only change that bool, like are the conditions right when the values of the scriptable object instance change. I just want to show you, you can do it this way too, right? You don't have to listen to the event. You can even use it in an update loop. Like an update loop could always check what's the value of the scriptable object instance and then do things accordingly. I hope you can see how useful this technique is, because all of those objects, they communicate with each other, but they don't know about each other's existence. Like the bulb doesn't have to find the sun and then in the sun script it has to like dig through the script and find, oh, that's the light value, and oh yeah, I need the heat intensity, do some calculations, and or maybe there's another thing that's doing the temperature or light. It only cares about the smallest possible thing, and that's the light and the temperature. That's the only thing it has a reference to. So they're really communicating through the smallest possible link, and that means things not gonna break when you remove things or add new things. But we should also talk about the downside of scriptable objects, and I think one of the most annoying ones is that values don't get reset because, well, they don't really care about runtime or not. So when you change them during runtime and you stop the game, they're still gonna have the different values here. This way I had this method set to initial value. And you might be tempted to just add like awake or in on enable in the scriptable object. But to be honest, it gets pretty messy. I'm gonna show a link in the description. There is a really nice Unity thread where people are trying to figure out when exactly those things get called. But it's not nearly as reliable as with the mono behavior. And there's some little caveats to it. So for example, on enable gets called when a scene is loaded, and the model behavior is referencing an instance of that scriptable object. So that means the first time it gets called when you hit stop and play in the editor, and the second time, then it's not gonna get called. And also awake, keep in mind that is getting called when an instance of the script gets created. So that means for the scriptable object, when you right click in the inspector, then awake is getting called, and that's not really that useful for game logic. That might be a nice utility. My advice would be have some kind of level manager that has reference to all these scriptable objects, and then in awake it sets them all to the initial value. Or maybe even depending on the level, it might say, no, in this scene we're starting with a different value. And what I also do is in a published game, I have a menu scene, and the menu scene can then look for a save game, can get that from the cloud or the hard drive. And if it says, okay, we're loading a saved game, I'm setting all the scriptable objects to the saved values. Otherwise, we're starting a new game. Okay, now I'm calling the set to initial amount on all these scriptable objects. And to make sure that there are no confusions, let's take a look at some examples when you would use a scriptable object and when you would not use them. So here's one of my favorite games, 2 Point Hospital. And my rule of thumb when to use a scriptable object is when every instance is going to be unique and used by more than one object. So there's only one global light in the example I showed you, right? There's no 2 global lights, 3 global lights. And here, a very good example is the player money. Like you don't have 1 wallet, 2 wallets. It's not like Bitcoin or whatever, where you make a new wallet. The player always has like 1 wallet. So you could just, there's going to be 1 instance. And also pretty much everything in the game is going to interact with this. Like the drinks machine is going to set that when someone buys a drink, you get $20. So the drinks machine prefab could have a reference to an instance of this float SO, and one float SO instance is player money. And the same like this reputation, this level, that's only going to exist once in the game. So on the opposite side, you would not use a scriptable object when there are like endless, maybe even an undefined amount of instances. So in this game, obviously, the patients, you don't know how many patients there are going to be, and they're definitely going to be a lot. And every patient that's not a patient is a pretty shitty hospital, to be honest. There's one, and even quite happy. So the patient is probably a class, and then you have those values here for happiness, health. Like those would just be values in a class because every patient has those, and they're all different for every patient. They're definitely not unique. And of course you create new patients, and I think one just died on the floor, so the instances get destroyed. And of course my own employees, there is a class, and everyone has those values. They're absolutely not unique. I'm gonna have a lot of those. And maybe even the drinks machine, it's a snack machine. Depending how often it was used, this value goes up and it needs to be repaired. Once again, every snack machine has its own kind of value here. They're definitely not sharing that. So you would not use a scriptable object for that. Just keep that in the class. Okay, this is it for this tutorial. I hope you learned something. As always, if you have any kind of questions, feedback, comments, just drop a comment below. Also, if you're interested, I can upload this project to GitHub if you want to look at the scripts. If anyone's going to request that, I'm going to do that. And yeah, subscribing to this channel would be really nice, but honestly, watching all the way to the end, that's actually worth a lot more. Yeah, thanks for watching and goodbye.